Thank you all for coming out to the webinar tonight. We are going to be using Tinkercad and learning a little bit about vector graphics. So again, apologies to those watching the video that would normally be in the 4 p.m. class. Mr. DeToy had a power outage happen right before the class started, so we were not able to find coverage for it. We will also have the new webinar invites out to you on Monday, so hopefully that will not be an issue in the future. So let's go ahead and go to Tinkercad. We're going to be at our dashboard page. So remember, that's going to be whatever design you had on here, your profile picture. I'm going to show you a couple things that may or may not pertain to what we'll be doing, but it is nice to know them. So if you're at your dashboard page, if you have more than one design made, you'll see them there. If you don't have more than one, you'll at least have the one we made last class. It should look something like this, maybe not like this, but overall what you'll see is when you hover over it with your mouse, you're able to see about a 180-degree view of your image. You should see the word private in the upper right-hand corner. I'll explain how to change that and what that means in a second. You'll also see a gear as well as a button that says Tinker This. So Tinker This, if you press that, will take you directly to your workspace so that you can play around with your design. Now, however, if you click on the gear, if you hover over it, it says Actions, but if you click on it, there's a couple options. Obviously, there's Delete. Don't do that unless you want to. There's Move the Project. This would mostly be used if you were making what they call a project, which is just several different designs that are meant to go together. There's Duplicate, which does exactly as it says. It's going to duplicate your project, so it's good if you want to change an existing design, but if you mess it up, it's not the end of the world. And then we've got Properties, which is going to be probably the most important of this for right now. So if you click on Properties, it's going to take you to a page that looks like this. So Tinkercad defaults to some bizarre naming by default. You will have a different name, obviously, but the name of the design I was working on is called Grand Fulfi. I don't know what that means, but if you want to rename it, this is where you would do it. Just whatever you want, because obviously that's kind of weird. You might like the name, you might want to keep it, it's your call, but in the future, if you were to 3D print something, you might want to consider renaming it so that it doesn't get confusing for whoever's printing it. So underneath that, there's something that says Public Access Settings. Right now, all of your designs should be private, and you can see that it is private by the purple private in the upper left-hand or right-hand corner. If you want to share it, not share it, but if you want to make it public, all you got to do is click on the drop-down. Don't worry about changing the license if you do want to share it. But if you do make it public, just be aware that other people can see your design. They can rate it, and hang on, there's some other things they can do, but you can share it if you want. It will be searchable in the search bar up here, but just know that's the consequence. Now, if you were to click on this design here instead of clicking on Tinker This or the gear, there's a couple more options here, and I see a question. They can copy it, yeah. What was I saying? Yeah, they can copy it, but they're not changing the original. Only you can change the original, if I'm not mistaken. So that's definitely a good thing there. So if you do click on it, there's a couple more options here. There's an option of View 3D, but I can't get it to work for whatever reason. So you can actually see it just regularly. And if you have any cool photos from your work plane, you can actually add that, but you probably won't do that. So here's where I said that you can see the comments and likes on it. So this is social, remember, so don't share anything you don't want other people to see. obviously. You'll see a couple options here, download for 3D printing being one. Now, you're not going to be doing any 3D printing in this class this year, but it will give you some files that are able to be printed by 3D printers, as well as 2D models for laser cutting if that is an option for you, which Mr. D has both in Charlotte, actually. You'll also see one that says download for Minecraft. I've never tried it myself, but I'd assume it's something like a custom skin, getting it into Minecraft. I'm not exactly sure, to be honest. I've never tried it. And there's also 3D print, or order 3D print here. Yes, you can order a 3D print of it through Tinkercad. I don't know how expensive it would be, but I'm assuming it wouldn't include shipping and handling. But if you make something that you're really, really proud of, you can definitely change it there. And you'll also notice that there's another, it tries to recreate it in Minecraft. Oh, really cool. Awesome. Doesn't work that great? Okay, not that cool then. You need MC Edit to import it into Minecraft. Okay. See, y'all know more than I do about this. I've never tried it myself, so. But all good stuff to know. But also notice that there's more options to tinker this. You can copy your design, you can duplicate it and play with the duplicated one. You can also take a look at the properties again, which is just right here. Okay, so you have to make it really big if you do want to to make it work in Minecraft. So, again, the things I'm hearing about it, you need MC Edit. You need to make it really big. It recreates it in Minecraft, but not very well. So, do with that what you will. But go ahead and go into your work plane of your item, however you may see fit. So, we're just going back to what we worked with last class, for right now at least. So if you do that, you'll see the same options here that you saw on the dashboard page. New, duplicate, save, and the properties, which will take you back to your name, as well as these downloading things for printing and whatnot, as well as other options to edit your design, and also you can view a tutorial or learn more about Tinkercad if you would like to. I've already gone over a lot of these things up top. A lot of these other things are just other buttons for the same thing. So real quick, let's go over all these, the tabs on the right hand side that I didn't go over last time. So favorites, you'll have to manually set your favorites if you have them. I never use favorites, to be honest. I normally just go into the geometric tab. We will be discussing import a little bit later. Import's pretty cool if you know what you're doing, but if you try to just import any random thing, it's not going to work out too well for you. There's some specific file types that you're able to import, and I'll tell you about that later. So shape generator, I can't speak. Shape generators is one of the big things that we hadn't discussed first. Both Tinkercad, like the people that work there, as well as some people that just enjoy it, have made some extra shapes that is not included in the geometric tab. So for example, polygon, here's a polygon that you can directly import and change as you will. So notice here that the inspector is actually extended. You can actually increase the number of sides of your polygon. You can choose how you'd like to define it. Right now it's defined by its radius, but you can also choose, for example, for the polygon at least, the apothem, I don't know what that is, or the length of the side, as well as the general size and the height, and if it's pointed or not. But basically all of the things underneath the shape generators and then the Tinkercad option will have this extended generator, or sorry, extended inspector on it. Notice that there is an image generator. It's not very good. You'll have a better time doing the method that we use later on. So, Again, the community also made a whole ton of these guys. Note the extended inspector for all of these. And I guess you can make your own shape generators, but I have never tried to do that. It might be a fun side project if you're interested in CAD programming, or sorry, CAD modeling. But that is the shape generator tab. Whatever helpers. Now Tinkerplay is one that I don't remember if it's new or not. I've never actually used it. But it's apparently pretty cool because you are actually able to create mechanical assemblies. So you can create, like arms and then use a ball joint to connect it. And you can actually see it move from what I gather about it. I've never used it myself. And we won't be using it in this class. But again, if you're interested in CAD modeling, you might want to take a look at it. Just saying. So whenever geometric, holes is just an easy way to bypass the whole inspector thing using the geometric tab. I never use this just because I never think about it. Showed you letters, numbers is very similar to that. Symbols is once again similar to that. And extras, which give you a couple of objects that are a little bit atypical, such as an egg, a little bit hard to model in Tinkercad, to be completely honest. But luckily they have it ready for you. And the best part about this is if you want to, you can make a bunny with an egg body. So, it might be something fun. But other than that, I think that is about the functionality that we've got here in Tinkercad. Any questions on what we've done so far before I go over the import option? Pretty straightforward so far. Again, a lot of this stuff is just getting used to it, playing around with it. So let's discuss the import option. So underneath the import option it says import 2D or 3D shapes from your computer from another website. So there's two options here, file or URL. File is the default. If you have a file that is of, I believe the options here you can actually see are going to be .stl, .obj, or .svg, you can import it into your work plane here. Now you probably won't have any of these files already prepared for you unless you have used another CAD software before. So here we're talking about AutoCAD, 123D Design. But you got to make sure that these files are one of these three types. Even if they are one of these three types, if they're too big, they may not import. If they're too small, they may not import. If Tinkercad isn't feeling like it wants to import, it's not going to import. It's really finicky. I've never tried to import a 3D object before into Tinkercad, but I have tried to import a 2D object, which is the .svg file. So you can either import it from a file or from a URL. So if you find something on the internet, if you have a direct link to it, you can upload it there. So I do see a question. Can you import from Mesh Mixer? That is a really good question. I'm not sure. If you want to give it a try, you definitely can. I think Mesh Mixer is just a mesh though. So unless the file type is one of the three, which it's not going to be SVG, it's either going to be STL or OBJ. If it's one of these two, you can definitely import it from Mesh Mixer. But I'm not sure if that's the right, or if Mesh Mixer is going to give you the right file type there. So give it a try and let me know what happens. Actually, look, it only looks like STL or SVG, maybe not .obj. But anyway, so we're going to talk about vector graphics. Is anyone familiar with vector graphics? Anyone heard the term? Maybe in a past Young Engineers of Today class. I think we did this spring of 2015. And if not, you're going to learn some fun stuff. Yeah, Mateo's right. It's just basically some lines, but It's a little bit more in depth than just lines, because that's like anything. So vector graphics specifically are the representation of images based on mathematical expressions. Still vague, right? The graphics are based on what we call vectors, or paths, which lead through locations known as points or nodes. Basically, a vector is a line that has a direction, so, maybe 90 degrees, and a magnitude, so 2 meters long. So it's got to have a direction and a magnitude. And the locations that these pass through are called nodes. So a vector graphic is just a bunch of vectors and nodes. So vector graphics are a little bit different than just the normal JPEG, GIF, BMP, PNG file. They're a little bit different. These files are made up of just a whole bunch of different pixels individually placed one by one. These kinds of file formats are called raster formats. And I'll show you how they behave differently than vector graphics do in a second here. So again, the vector graphics are made of these paths and vectors that have start and end points as well as curves and angles. So if you had an image processing software that can handle vector graphics, so we're looking at Photoshop, we're looking at Inkscape, which is what we used last year actually to play with this, you can actually see more in depth of how they work. Vector graphics are one image, but they're broken up into a whole bunch of little primitives. Primitives are just geometric shapes, like points, lines, curves, polygons, which we overlap on top of each other to make more complex shapes or diagrams. So these paths can be very, very simple or a little bit more complex. As you can see, one of these cells, which is just a little fraction of an image here, can be comprised of 5 different primitives laid on top of each other. We start with that base of the tannish of the lion. We have a little bit darker for the second layer just for shading. Then we've got the pink nose on top of that, and on top of that we've got the black for the outline of the nose. So it can be very simple, it can be very complex, but some typefaces are actually a type of vector graphic too. And I haven't even taught you about the coolest stuff about vector graphics yet. So unlike raster graphics, vector graphics are not limited by a certain resolution. And what I mean by this is, if you take a raster image, say it has a resolution of 240 by 360, this is like a finite set of pixels. It's going to be 240 pixels by 360 pixels. So if you wanted to blow it up and make it look a lot bigger, it's going to look pixely. So just like here, if we have an image of some weird ice cream soda, if we want to blow it up in a raster format, we're going to get pixels. But with vectors, they're a little bit different. Vector graphics edges will stay very smooth and clean because they're not defined by pixels, they are defined by these vectors. They're defined by, again, a line with a shape, with a direction and a magnitude. So vector graphics files are just a whole bunch of curves put together that you can make as big or as small as you want without losing the quality of your image. That's why these are really handy. And that's also why we can import them into Tinkercad. So we actually haven't played around with Scratch. But notice that if you were to, and take a look at the Scratch cat here, you can see another example of why vector graphics are generally superior to bitmap. So vector graphics are also used a lot to make logos, or used in logos rather, because you can make them small, say for the head of a letter, or you can make them enormous, like putting them on a billboard, without changing the graphic at all. They also usually will take up less physical space on your hard drive than a raster image, so animations use them quite a lot. So we're actually going to go on the internet now and look up a vector graphic. So in this case, let's say we're going to look for a duck. Now, what if we wanted to make this duck look different in a whole bunch of different places? Actually, that's not really relevant to this, so never mind, ignore that. So what we're going to do is go to Google Images. So we're looking at images.google.com. Alright, can everyone get over to that? I'm going to show you, obviously you know how to search for an image, hopefully, but I'll show you how to change your search settings so that you can find some vector graphics. So in this case, what I'm going to do, I'm looking for a duck graphic. So what I'm going to do is just type in duck into Google Images, and there's some really adorable ducks here. But we can't just take any of these images and throw it into Tinkercad. We have to refine our search to make it possible for us to do so. So to do that, let me double check I'm doing this right before I tell you. Okay. So to do that, what we're going to do, once we've searched, we're going to go find the gear in the upper right hand corner. Oops. Which should say setting or options when you hover over it. And we're going to scroll and click on Advanced Search. So Advanced Search is really nice for a whole bunch of different reasons, because you can see, image size, the aspect ratio of it, the kinds of colors of the image, the type, where the image was taken, all sorts of stuff that you probably wouldn't ever have to worry about unless you got a job in graphic design later in life. But ultimately, most of the stuff's not very important, but we're going to scroll down all the way to file type, which should right now be at any format. And so I do see a question. You're a graphic designer already? Nice. I don't even know if you'll use it for that, honestly, but I can't think of any other jobs where you may possibly need to go into the advanced Google image search function. But we're going to go to file type, and you'll notice that you're making graphics for Mother, like Earthbound. Oh, nice. I've only played the first, hour of the game, the first game, but I like what I played. But that's pretty cool. I didn't even know they released it recently in North America, but yeah, that's awesome. So you'll notice under file types, there's a whole bunch of different raster graphics that I had told you about: JPEG, GIF, PNG, bitmap, and then a couple file types I'm not sure about. But the one we're looking for is the SVG file. It stands for something vector graphics. I really don't know what the S stands for. It just worked out that way. But we're going to click on SVG files, and everything else is going to stay the same. So all I got to do now is advanced search, and it's going to return you only the SVG files that match the phrase duck. So when you're importing it into Tinkercad, just based on my experience, it works out better if you pick an image that has fewer, doesn't have many colors, maybe just a line, or maybe a line or just with one color like this. But those tend to work the best. So go ahead and pick one of those out. It doesn't have to be black and white, but just pick one without too many colors. And save it somewhere where you can find it, so maybe on your desktop. And so you're saying learning how to change graphics to vector would be sweet. We actually did that last spring, which I'm kind of sad we didn't decide to proceed with it this year. But if you download this, yeah, if you download this software called Inkscape, I'm sure that there are tutorials online on how to convert your raster graphics to vector. You know about Inkscape? Okay, because that's what we use to do it in here, and I think the biggest problem was getting it installed, but there are guides online on how to make a raster graphic into a vector graphic using that, and it works really well actually. So cool. But yeah, so one thing I forgot to mention, if you're going to, actually, hang on one second, let me collect my thoughts. I mentioned earlier that you could either save the file or find the URL. Does anyone remember when I said that earlier? So if you save the file, you want to make sure you save the actual SVG file and not just, you know, the JPEG image here. So you'll actually, if you're going to save the file, you need to click on it and then click on View Image, and you can save it from there by going to right-clicking and clicking Save As. Now you'll also notice you can do it from a URL. You can also just take this URL right here. It should end in .svg. You can take that and directly import it as well into Tinkercad. Now, I mentioned earlier that it is a little bit finicky. It gets mad at you sometimes for no reason. So if it doesn't work the first time, try importing it one more time. Actually, wait, I'm getting ahead of myself. I'm going to go ahead and do it via URL, but if you saved it, you want to make sure to click on File, back over in Tinkercad, and then choose File. And then Import. So I'm doing a URL. So I'm just going to literally paste the URL and then click Import. You'll notice that after you enter in the URL, what should pop up are two buttons that say Scale and Height. You want to keep your default height to be 10 millimeters. That's a good height usually. But you might need to scale it. So if you saw how big it looked right over here when I first downloaded it, it's not very big, but look how much bigger it is if you import it. So if you try it and it imports and it's too big, make sure you've got it selected and then click on your delete key to take it out, and then try re-importing it maybe at 75%. You can also resize it just manually if you want. So I want you all to go ahead and make sure that you are able to import an SVG file, which is a vector graphics file, into Tinkercad. I'm going to put your hands down. I want you to raise your hand if you successfully imported an SVG file into it. And this isn't crazy difficult. If you're having issues, it's more than likely just your the image you picked is just not working happily with Tinkercad, which happens, and it's not your fault generally. You did it nice. So in past years, we did this to 3D print checkers. So normally what we would do in past years is have you create a cylinder of a certain height and center your duck or whatever you created on the checker so that we could 3D print it. We would then cast and mold it, which is basically just making a inverted copy, and then using this inverted copy into making a regular looking copy. But we're not doing that this year. We're focusing on just plain old CAD. Still talking with Mr. DeToy and Mr. Dubik about what our next software is going to be, because Tinkercad's pretty easy. I mean, I basically have gone over everything that you can do with Tinkercad already. Obviously, I haven't done very much in terms of having you build stuff in Tinkercad, but luckily this stuff is pretty fun. Oh, you made a Tardis in Tinkercad? Was it you that posted that earlier in Edmodo? It was? Alright, did you share it as public? I think I liked the picture, but I don't remember. Let's take a look here. Oh, you made K9 too? Oh wow, that looks really good. You even sized it correctly and everything. But this is an example of some of the stuff that you could do in Tinkercad. It's literally just building blocks, basically. That's all that he did. Probably spent a lot of time on it, but still a pretty impressive. Let's see if I can actually see it in 3D. It's been not. Oh, it's actually working. Cool. Exterminate. But yeah, cool. So one of the things you can do in Tinkercad, I'm going to show you also one of what my architecture camp students did this past summer. So remember, just like y'all are doing here, they did this all with Tinkercad. I'm going to go into Tinkercad proper to show you. So look at that. It actually printed out pretty well too. She spent, I know it's a copy of a copy. I had to do that to, well, I actually didn't have to do it. I just wanted to do it to make it, or to show off. But yeah, this took her about 2.5 hours, I think, to do. And notice it's not even done loading yet. You still can't even see everything all that well. But yeah, this is very possible to do in Tinkercad if you are brave enough, if you want to put forth the effort. Now, I had one more too that was also pretty cool, but it unfortunately suffered from being, it's not as cool as the other one, I don't think. But this one was actually created in Sketchup, which is another 3D modeling software. And I had to actually fix it because it behaved a little bit weird when I did. Oops, let's get this. Some of the pieces of it just sort of disintegrated, as you can see down here. Oops. I had to rebuild part of the pillar. It just happens when you're importing different software, or different stuff from softwares and different softwares, but yeah, I had them build houses and stuff. It was a lot of fun last summer, but you can do this in Tinkercad. You have the capability. It's just trial and error. That's really what you're looking at here. Alright, so how are we looking at on time? 6:40. I think the only thing I haven't gone over about Tinkercad is a little bit of an intro to 3D printing. Because we're not 3D printing though, I don't know if I want to actually go over that. So I'm going to do a quick show of hands here. Who's interested in a very, 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 very basic overview of 3D printing? Alright, I'll go ahead and do this overview real quick then. It's not going to take very long, so give me a second to open her on up and find it. Oops. I wasn't sure if I was going to get this far or not today, so cool that we did. Alright. So again, this is a very, very high level, very simple outline of 3D printing. So 3D printing is what we call additive manufacturing, which means that you're creating an object of any shape just from a digital model. You're building it from one layer to the next. This is opposed to what we call, I think it's called subtractive manufacturing, which is basically like sculpting. You would take, a block of stone and take stuff off of it to make it what you want. So that was the old school version of doing it. Nowadays, 3D printing, you use additive manufacturing for it. The basic overview of how 3D printing works, you design something in 3 dimensions using a 3D modeling software just like Tinkercad or Sketchup or AutoCAD or any of the other millions of softwares. It is sent to the 3D printer, which renders it in a certain way. It understands the file, and the design is then assembled layer by layer. So like I said, it is a little bit different because it uses additive manufacturing as opposed to subtractive manufacturing. And the difference in the kinds of 3D printing, there's a couple different types, but it's mostly just on how the layers are assembled. So among many, many other things, here are a couple of examples of 3D printed objects here. They're very diverse. As you can see, 3D printed guitar, 3D printed crazy looking thing. We've got a 3D printed chocolate mold, and we also have a 3D printed jawbone. So not only can you do it for fun or to look cool or anything like that, but you can also use it for health purposes. So think of like a prosthetic leg. You could definitely 3D print one of those, given enough time, obviously. So back in the 70s, I believe, there's this guy named Chuck Hull. He is the father of 3D printing. He invented this process called stereolithography, which is a very old prototype of 3D printing. I can't remember specifically. I might go on YouTube in a second here and show you what stereolithography looks like. But it was the first 3D printing machine. He also invented the STL file format, which is like the flagship format for 3D printing. So if you remember what I said earlier, STL or SVG, check it out. Even today, .stl files are used for 3D printing. So 3D printers, especially since the 70s, and especially in the past 10 years, have gotten smaller, faster, and cheaper, to the point where the Science House, which is where Raleigh folks have their labs, has 5 or 6 of their own 3D printers. Mr. D has 10 or 15 printers and a milling machine. He has 13 3D printers. Okay. Wow, I was actually really spot on there. Cool. But his are way nicer than the ones at the Science House. But it's to the point now where we can actually use this in education, so you can see how it works. It's some cool stuff. There are also open source 3D printers, unlike the ones that we use. One being called the RepRap. It is the first 3D printer that could actually theoretically print itself. Whether or not they've actually tried it before, I don't know. And I know for a fact that they have not been able to replicate the electronics of it. They can't do that quite yet in 3D printing. NC State probably a year and a half ago just created some metal 3D printer, which I'm still not sure how that works, but soon we'll be able to completely create a self-replicating machine for sure. The designs that RepRap has are free to share and use. Again, they're open source. So anyone can change them, anyone can add to them and make them better. So MakerBot's probably the most famous, or one of the most famous companies making 3D printers now. They have a MakerBot called the Replicator. The founders of this 3D printer are from the Maker community. So that's like a community that they could hack electronics, they make stuff out of other stuff. Nowadays they do a lot with the Arduino and the Raspberry Pi, which are microcontrollers. And coincidentally, the 3D printers that are both in Raleigh and in Charlotte, the Polar 3D, they use a Raspberry Pi microcontroller to work. So these Maker people are actually the not the founding father, but they did a lot for 3D printing. And they also helped create this thing called Thingiverse. So Thingiverse, which is probably going to be the last thing we go over today, is a big repository of designs people have created. So it's thingiverse.com. I'm going to go check that out right now. I think it works better if you have an account, just in terms of searching for stuff. Yeah, you'll need a MakerBot account for it, which I don't think I have one actually right now. But it's one of the bigger repositories of 3D prints, or 3D printed, of 3D modeled things. So there's some really cool stuff actually that you can find on this site. One cool one that I found and printed several times last summer, this guy right here. So if you do want to take something off Thingiverse, make sure you've got the STL file, because from there, okay, why aren't you working right now? From there you can put it into Tinkercad and play with it that way. So in a second, when this decides to load, you'll see just how detailed this is, and how difficult it probably would have been to create this directly in Tinkercad. Does anybody remember from last class what I said about what makes Tinkercad different than other CAD modeling softwares? Anybody remember what I said about that? Tinkercad is an anomaly here. Whoa! Tinkercad is different because most CAD modeling softwares will take a line or a circle and pull it into 3 dimensions. Whereas Tinkercad starts in 3 dimensions and ends in 3 dimensions. So something like this would have been incredibly difficult to create in Tinkercad. Just because you're limited to these shapes here. You could try making it, you probably won't have a good time. That's what the other CAD softwares are good for, and are superior in overall. So like I said, if you want to make an account on Thingiverse and search for stuff, somebody tell me a word that I'm going to search. Anybody? An appropriate word. Okay, Tardis. So I guess you can search some stuff, but I do think it works better otherwise. But take a look at all the Tardises, which are something from Doctor Who, that people have created. Someone even created a Tardis transformer. And as long as you click download this thing, oops, as long as underneath thing files there is a .stl file there, you will be good. So another good point being made is that if you have a Raspberry Pi, the microcontroller I was just talking about, there are all sorts of cases for it that you can... You have 7 Raspberry Pis? Goodness. That's awesome. So if you have a Raspberry Pi, there are cases that you can put into Thingiverse and put into Tinkercad and customize it as you see fit, and then 3D print it. If for some cool reason you do have the option to do, or if you do have a Raspberry Pi, you do have the option to print a case for it, I recommend that when you print it, make sure it's just a little bit bigger than the default when it is printed out. So instead of printing at 100%, print it at 102%. 3D printers are not perfect. I've wasted a lot of thread printing something that a Raspberry Pi will not fit in. So there's all sorts of stuff that you can search, and as long as they've got an STL file, so to check on that, you click on it, click on thing files, .stl. As long as you got that, you can import it into Tinkercad and play with it as you would like to. And yeah, that is a pretty cool Raspberry Pi Nintendo case. I think I had one student do this in the summer, but it does look really cool. So I know it's a little bit early. I'll type in this one last thing. It's not that, right? Like I said, I know it's a little bit early, but I don't have anything else for today, so if you'd like to leave, you can. I'll be on for a couple more minutes, though. Yeah, I didn't think this was it. If you do want to leave, you're more than welcome to. If you don't want to leave and just want to search for stuff and get excitable about it, that's cool too. So, thank you all for coming out, and I hope you have a good night.